Welcome to our introduction to inequalities, and actually this is lesson 1, not lesson 3, so that's a typo if you want to correct that on your paper. So today, before we start working with inequalities, we're going to kind of compare them to expressions and equations and see what we find similar and what we find different. So an expression is generally numbers and or variables, and usually it contains an operation sign, meaning adding, subtracting, multiplying, or dividing. So I'm going to start with a very basic numeric expression. I'm going to start with 3 plus 5. So this expression contains numbers, and it has the operation of addition. And the nice thing about a numeric or numerical expression is that we can figure out what the value is. But that's not necessarily the case when we work with an algebraic expression. For instance, if I said x minus 10, that's an expression also, just has a variable and a number and an operation, but I would not be able to state what the value of the expression is. And it doesn't necessarily just have to be adding and subtracting. It could be multiplying, dividing, raising to a power. For instance, I don't even have to have numbers. Another algebraic expression would be x squared. So that's what an expression is. So now let's take a look at an equation, and let's again start with a numeric equation. So for instance, if I said 3 times 6, an equation must have an equal sign. So it could be numbers, again operations generally, and I would say that that's 18. So what's special about an equation is that both sides must have the same value. They might look totally different. This looks different than 18, but the value is equal. They're both equal on both sides. And I've heard an equation sometimes being defined as two expressions that are equivalent or equal. That's another way to look at it. So now let's look at what an algebraic equation would look like. We could have n plus 4 equals 12. And even though we have a variable, we now have enough information because we know that what this side equals. We now have enough information that we can figure out what the value of n has to be. And there's only one number that would make this equation true, because this side has to have the same value as this side. This side has to be 12, and so this n must be 8. So when we work with equations that are algebraic, we're given enough information to figure out what the value of the variable is. So now let's move on to an inequality. Like an equation, an inequality makes a comparison between two sides. But unlike an equation, the two sides are not equal. The comparison an inequality makes is that one side is greater, the value of one side is greater or less than the other side. So let's give ourselves an example of an inequality using numbers. For instance, if we had 7 plus 3, and I wanted to use the less than symbol, the point to the smaller value. So 7 plus 3 would be 10, so whatever I put on the other side, 10 is smaller than this number. So as long as I use 11 or above, or for that matter, 10 and 1/10 or 10 and 2/10, we could start working with fractions and decimals. As long as the number on the other side meets this standard, that what is ever on this side is smaller than whatever is on this side, we've written an inequality. So that's what it looks like in numbers. We can also work with an inequality that has a variable. For instance, if I said that 4 times, let's try y, 4 times y is greater than or equal to whatever I write here, I'm going to write 20, then this variable y times 4 would have to give me a value that is greater than or equal to 20. And this is what we're going to explore more and more. So let's now move on and let's start working with some definitions. So here are two basic inequality symbols. And when we talk about how to read them, often it's confusing because they look similar. They just point in different directions. And we're going to, when we read them, we read from left to right. So when we look at this symbol, we see the open end, the larger end first. So this is referred to as the greater than symbol. Sometimes we use more than, so you can use either one of those wording, although greater than is more prevalent. And then when we look at this other symbol, reading from left to right, we run into the point, the small part of this symbol first. So we usually refer to that as the less than symbol, or sometimes we can say fewer than. So when we read these, for instance, if I have the greater than symbol, whatever number or value I run into first on the left side has to be larger than whatever is on the right side. And so an example of this would be 9 is greater than 4. So that's true. 9 is bigger than 4. But we're going to start using this algebraically. So I might say that x is greater than 4. So as long as I choose any number that is larger than 4, x can be any number. It doesn't have to be 9. It could be a different number. In fact, many numbers, and we'll discuss that later. Moving on, this next symbol, I see the point first. So whatever is on this side must be smaller in value than whatever is on the right side. So an example of that might be 12 is less than 15. So if I'm going to use this in algebra, the variable doesn't have to necessarily be on the first side. I could write 12 is less than this number x. So that means if I were going to write this or figure out what x would be, 12 has to be smaller than any of the values I put here. So these two symbols, again, they look very similar. They're just switched orders, so this is important that you write this down and try to remember it. For both of these symbols, the open end, so the open end, the larger, what I look at as the larger end faces the larger or greater number, and the point faces the smaller number. However, since we read from left to right, if we see the open end first, we call this the greater than symbol, and if we see the point first, we call it the less than symbol. So our next inequality symbols just add another layer. We can see that we have the greater than symbol, but we've added another little line to that. And I always kind of got a kick out of that because it's called the greater than or equal to symbol, and I thought it really doesn't take that much more work to write the rest of the equal. But we just use one line, even though they apparently didn't ask me when they're making up this symbol. So we call this the greater than or less than, greater than or equal to symbol. And then when we look at this, we see the smaller end, so this is the less than or equal to. All right, there's one other symbol that I didn't put on here, and it would be considered an inequality because it's stating that the two sides do not have the same value, and that would be the not equal to symbol. So let's move on to the second page, please. So again, we're going to keep in mind that the point faces the smaller number and the open end faces the larger number. So I'm going to go ahead and highlight that the point faces the smaller number and the open end faces the larger number. It continues to say we can draw a number line to help us compare these numbers. The further a number is to the left of the is the left on the number line, the smaller it is. Meaning if I put a point here, so we'll try that, and I put a point here, even though my brain might register that 12 is bigger than 4, you're going to notice we're on the negative side. So on the negative side, this would be considered a loss of 12, and this is a loss of 4. So I would have, for instance, less money if I lost $12 opposed to losing $4. So let's look at the examples below and see if we can place the correct inequality sign in the box. So if I'm looking at this example, you may not need the number line for this, but I can see that 9, it's positive, is bigger than 4 or greater than 4. So I'm going to choose a symbol whose open end faces 9 and smaller point faces 4. So this would be read as 9 is greater than 4. So now let's look at the next example, and this example might be a little bit easier if we demonstrated it on the number line. For instance, if I put negative 12 on the number line and I put positive 7 on the number line, the reminder is the further number is to the left, the smaller it is. So once again, 12 might appear to us to be bigger than 7, but it's a negative 12. So the point in this case should point to the 12, which is smaller, and the open end should face the 7, and this is read as negative 12 is less than 7. Now when we go to do this example, I'm first going to have to work on some calculations before I can place the proper symbol in this box. So if I had 1 minus 9, the value would be negative 8, and you're welcome to use your calculator if you like. And then on the other side, you have a negative 3 plus negative 4. When they're both negative, I'm adding them. I add their values together and keep it negative. So I have a negative 7. So now that I know what each side value is, I can see that negative 8 would be further to the left of my number line than negative 7. So my smaller number is the negative 8, and my larger number is the negative 7. So the point smaller end faces 8, and the larger end, the open end, faces negative 7. So this is a symbol that I should use here. So would you please try the following examples on your own, and then you can check back for the key. Thanks for listening, and tomorrow's lesson will focus on how we graph an inequality. Take care and have a good rest of your day.